This topic is about Huffman coding. Let's get into the topic. First of all, what is Huffman coding? It is a technique which is used in compressing the data to a smaller size without losing the details of the original data. Huffman coding is generally used to compress the data which consists of the frequently repeating characters. And it was developed by David Huffman, who designed this code in the year 1951 as a part of term paper. It is one of the most popular greedy algorithm code as they are variable length codes because the size of code assigned to a character depends on the frequency of the character. The character with higher frequency gets a shorter length variable code and vice versa for characters with lower frequency. It uses a variable length encoding, which means that it assigns a variable length code to all the characters in the given stream of data. It is a bottom up approach code. Huffman coding prevents any ambiguity in the decoding process using the concept of prefix code. That is, a code associated with the character should not be present in the prefix of any other code. There are two major steps involved in Huffman coding. They are first, constructing a Huffman tree from the given input string or characters or text. Then, assigning a Huffman code to each character by traversing over the tree. Next comes the Huffman coding algorithm. The first step is to list the symbols and sort them based on the frequencies in an ascending order. The second step is to pick two symbols having low frequencies. The third step is to create a new node by adding probabilities of symbols, which are selected in step 2, and label the new node with it. The fourth step is to repeat steps 2 and 3 until only one node remains. The next step is to start assigning code 0 for the left child and 1 for the right child for every internal nodes. And the final step is to construct the code for every leaf node by tracing the code from root to leaf node that represents each label. Now let us understand the concept of Huffman coding more clearly with the help of an example. Now let us look into an example. A file contains the following characters with the frequencies as shown. If Huffman coding is used for data compression, determine the following Huffman code for the following character, the average code length, and the length of the Huffman encoded code in bits. Let us consider there are four symbols A, B, C, and D having frequencies 16, 12, 3, and 4. So the first step is to sort the symbols in an ascending order. The second step is to pick the least two frequencies and combine them. Here, the least frequencies are symbols C and D having the frequency of 3 and 4. We need to add 3 and 4 to get the value 7. The next step is to repeat step 2. Here, we take the next least frequency value 12 and we are adding it with the value 7, so we will be getting a new value 19. Again, we are taking the remaining least frequency 16 and we are adding 16 with the last time got value 19. By adding 19 and 16, we will get a value of 35. This is the Huffman code for the given data. Next, to find the Huffman code for each characters, we are assigning weights to all the edges. Let us assign weight 0 to left edge and weight 1 to right edge. Here 0 and 1 are prefix codes. For symbol A following the arrow path, we will get 0. For symbol B, we will get 1 1. For symbol C, we will get 1 0 0. And for symbol D, we will get 1 0 1 respectively. In order to find the average code length value, we are using the formula given below. That is, sum of frequency I multiplied to code length I divided by sum of frequency I. For frequency, we are taking the frequencies of symbols A, B, C, and D, that is 16, 12, 3, and 4. And for code length, we are taking number of bits, that is, if 0 means 1, 1 1 means 2, 100 means 3, and 101 means 3. By multiplying and dividing the values, we will get average code length value. To find the complexity analysis, the algorithm uses a priority queue based on the minimum heap data structure. The root of the minimum heap contains the minimum element. Then, removing the root and adjusting it would take theta log m time. The loop takes at most n minus 1 steps. Therefore, The complexity is theta n log n.